You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Data retention is the disciplined practice of defining how long specific records and datasets are kept before they are securely disposed of. Unlike ad hoc storage, retention is guided by policy, whether for compliance, operational need, or business continuity. Some records must remain accessible for decades, such as financial statements governed by regulatory mandates, while others may be held only briefly for operational troubleshooting. Retention is not just about keeping data, it is about ensuring that data is preserved for the right duration, in the right form, and in the right location. Without such discipline, organizations risk both regulatory penalties for premature deletion and increased liability from hoarding unnecessary data. In practice, retention strategy becomes a delicate balance between legal requirements, business utility, and cost-effective storage practices. Backups form the cornerstone of retention, providing independent copies of data for recovery from corruption, deletion, or ransomware. Unlike archives, which are optimized for long-term storage, backups are designed for rapid return to service. A backup represents a known good state that can be restored when disaster strikes, whether caused by malicious encryption, accidental deletion, or hardware failure. The critical distinction is independence. A true backup must exist separately from the original system, ensuring that compromise of the source does not automatically compromise the backup. This separation makes backups a digital safety net, much like insurance policies, rarely used in ordinary circumstances but invaluable in moments of crisis when continuity hangs in the balance. Archival, by contrast, is about cost-optimized preservation of data that is infrequently accessed but must remain durable. Cloud providers offer specialized archival tiers where data is stored at low cost with retrieval delays measured in hours rather than seconds. Examples include regulatory documents, historical records, or scientific datasets that need to be retained but are seldom used. Archival storage emphasizes durability and compliance rather than speed, offering a digital equivalent of deep storage vaults. By separating archives from active systems, organizations reduce costs without losing access. The challenge lies in planning. Retrieval archive data is not instantly accessible, and delays must be factored into operational workflows or compliance responses. Versioning is another dimension of retention that protects against unintended overwrites and deletions. Instead of overwriting files or objects in place, versioning preserves prior states, allowing rollback to earlier copies. Cloud object stores often provide built-in versioning features that capture every update, giving administrators the ability to recover from mistakes or malicious changes. This is particularly valuable in scenarios where files are collaboratively edited or automated systems modify datasets at scale. Versioning functions like a time machine, offering the ability to rewind and recover what once existed. Though it requires careful management to avoid storage sprawl, versioning offers a practical, flexible safeguard that bridges gaps between backups and archives. Recovery Point Objective, or RPO, defines how much data an organization can afford to lose when a disruption occurs. It is measured in time. If RPO is set at 4 hours, then no more than 4 hours of data changes should be lost. Meeting an RPO involves planning backup frequency, replication intervals, or journal-based logging. A tighter RPO, say minutes instead of hours, demands more aggressive solutions and higher costs, while a looser RPO reduces overhead but increases potential loss. RPO frames resilience in concrete terms, giving leadership a clear understanding of acceptable risk. Much like deciding how often to save progress in a video game, RPO captures the organization's appetite for risk against the cost of assurance. Recovery Time Objective, or RTO, measures how quickly a system must be restored after an outage to meet business needs. While RPO concerns data loss, RTO focuses on downtime. A bank's online services might require an RTO of minutes, while an internal reporting tool may tolerate hours. Meeting strict RTOs requires investments in replication, automation, and orchestration. delayed RTOs can mean lost revenue, frustrated customers, and reputational damage. The tension between RPO and RTO is a central design challenge. Both must be balanced against cost, complexity, and organizational priorities. Together, they set the guardrails for business continuity planning, defining what acceptable looks like in the face of disruption. Snapshots are a common mechanism for meeting tight RPO and RTO targets, capturing point-in-time states of data. Unlike full backups, snapshots are often incremental and space-efficient, relying on underlying storage systems to track changes. They provide rapid local recovery for volumes, virtual machines, or objects, enabling near-instant rollbacks. Snapshots are invaluable for protecting against human error or localized corruption, but they are not substitutes for full, independent backups. Because snapshots often reside on the same infrastructure as production data, they are vulnerable to systemic failures or attacks that compromise the environment. Used wisely, snapshots are quick response tools, offering agility while larger backup and archival systems provide depth and independence. Replication strengthens resilience by duplicating data across devices, zones, or regions. It ensures that no single hardware failure or site outage can eliminate access to critical information. Replication can be synchronous, maintaining perfect copies in near real time, or asynchronous, trading immediacy for efficiency. In cloud environments, replication across regions also addresses sovereignty and compliance, ensuring that data remains available even during large-scale disruptions. However, replication alone is not a backup. If corruption occurs in the source, it may be replicated instantly to all destinations. Replication is like having multiple mirrors of a document. It prevents loss through single-point failure, but must be paired with backups to guard against logical corruption. Write once, read many, or WAMA, and immutability controls add another layer of assurance by preventing alteration or deletion of data during defined retention periods. These features are critical for compliance in industries like finance or healthcare, where regulators require that certain records remain untampered for years. Worm storage enforces integrity by design. Once written, the data cannot be changed until the clock expires. Immutability also defends against ransomware, preventing attackers from encrypting or deleting protected copies. It is the digital equivalent of sealing documents in a tamper-proof vault. For organizations seeking both compliance and resilience, immutability provides confidence that critical records remain inviolate, even in hostile conditions. Application-consistent backups address the complexity of modern workloads by ensuring data is captured in a transactionally sound state. Simply copying files risks inconsistency if applications are mid-write, leaving restored data corrupt or incomplete. Application-consistent backups quiesce workloads, flushing buffers and pausing transactions to ensure a clean, recoverable snapshot. For databases, this means backups reflect coherent states that can be restored without manual intervention. For virtualized systems, tools coordinate across operating systems and hypervisors to capture synchronized images. Application consistency requires more planning than crash-consistent snapshots but pays dividends during recovery, eliminating guesswork and failed restores. It transforms backups from hopeful insurance into reliable recovery instruments. Deduplication and compression reduce the storage footprint and transfer time of backup sets. Deduplication identifies repeated blocks of data and stores them only once, while compression reduces redundancy within files. Together, they dramatically shrink the size of backup repositories, lowering costs and accelerating transfers to cloud storage. For example, daily backups of similar operating system files may consume vast space without deduplication, but with it, only changes are recorded. These optimizations make large-scale retention feasible, especially when data must be stored for long periods. They also reduce bandwidth usage, making off-site replication and cloud-based backups more efficient. Deduplication and compression thus serve as quiet enablers, amplifying both performance and cost-effectiveness. Encryption is indispensable for protecting backups and archives, both at rest and in transit. These datasets often contain the most sensitive information in concentrated form, making them prime targets. Strong encryption, tied to rigorous key management, ensures that even if media is lost or stolen, the data remains unreadable. In cloud scenarios, encryption prevents exposure during transfer to remote storage and enforces confidentiality in provider-managed infrastructure. Key custody becomes central. Organizations must decide whether to use provider-managed keys, customer-managed keys, or hybrid models. Without encryption, backups turn from safety nets into liability magnets, offering attackers a consolidated trove of sensitive information ripe for exploitation. Catalogs and indexes are the navigational aids that make backups usable. Without them, locating the right version of a dataset across thousands of backups would be an exercise in futility. Catalogs record metadata about backup sets, their locations, associated versions, and retention clocks. They allow administrators to search, retrieve, and restore efficiently. Indexes also enable compliance audits by showing that specific records were retained or deleted according to policy. A well-maintained catalog is like a library index. Without it, the collection may exist, but its contents are effectively lost. Catalogs transform raw storage into an organized, recoverable archive of institutional memory. Legal holds provide mechanisms to suspend retention policies temporarily, preserving specific records for investigations or litigation. When a hold is applied, automated disposition clocks pause, ensuring that data remains available until legal matters are resolved. Legal holds are essential for regulatory compliance and litigation readiness, demonstrating that organizations can preserve evidence without altering or destroying it. They also highlight the intersection of law and technology, where retention policies must adapt to judicial requirements. Just as a court may issue a stay to halt proceedings, legal holds act as injunctions against data deletion, prioritizing accountability and due process over ordinary lifecycle rules. Policy tiers allow organizations to adjust backup frequency and retention duration by classification, criticality, and regulation. Critical transactional data may require hourly backups and multi-year retention, while less vital logs might only need weekly captures and short-term storage. Tiered policies optimize cost and resilience, ensuring high-value assets receive maximum protection without overwhelming resources. This tailoring is essential in cloud environments, where storage costs scale directly with volume and duration. Much like airlines offering economy, business, and first-class seating, policy tiers ensure differentiated service levels that reflect both value and risk. By aligning retention with business priorities, organizations maximize return on security investments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A cross-region strategy is one of the most powerful ways to safeguard against large-scale outages. By replicating backups and archives into geographically separate regions, organizations protect themselves not only from hardware failures, but from natural disasters, geopolitical events, or regional provider outages. The challenge is balancing sovereignty laws, which may restrict where data can reside, with the latency and costs of storing copies across borders. For example, a European bank might keep a primary backup in-country for compliance while maintaining a secondary replica in another EU region for disaster recovery. This approach provides resilience while respecting jurisdictional boundaries. Cross-region planning reflects the reality that disasters are not limited to single data centers, and that true durability requires geographic diversity in storage strategies. Rehydration planning becomes crucial when relying heavily on archival storage tiers. Archival systems are designed for cost savings, but retrieval can be slow and expensive. Rehydration refers to the process of pulling archived objects back into active storage for use, and organizations must estimate the time and financial costs involved. For instance, restoring hundreds of terabytes from deep archive tiers could take days and incur significant retrieval fees. By modeling likely scenarios in advance, Administrators can decide which data can safely live in cold storage and which requires faster tiers. The process is akin to thawing frozen food. While preservation is inexpensive, readiness for use takes time, planning, and resources that must be factored into operational strategy. Restore testing validates that backups and archives actually fulfill their intended purpose. Too often, organizations assume data can be restored only to discover failures during a real incident: corrupted files, missing dependencies, or misaligned formats. Scheduled restore tests, guided by runbooks and mapped against dependencies, provide assurance that recovery objectives are achievable. These tests also help measure whether recovery time objectives and recovery point objectives can be met in practice. Regular validation transforms backups from theoretical safety nets into proven instruments of resilience. It mirrors a fire drill in a building. Without practice, evacuation plans remain untested, leaving lives at risk when disaster truly strikes. Chain of custody documentation provides auditability for every backup and restore operation. It records when data was copied, who accessed it, and under what conditions it was restored. In legal or regulatory contexts, such documentation demonstrates integrity and accountability. Without it, questions may arise over whether data was altered or mishandled during retention. Chain of custody is especially critical for highly sensitive fields like healthcare and finance, where evidentiary standards are stringent. The process is comparable to tracking the handling of evidence in a courtroom. Every transfer and interaction must be logged to preserve credibility. In retention systems, this discipline provides both transparency and protection against disputes. Backup windows and performance tuning ensure that the process of creating copies does not unduly disrupt business operations. During busy work hours, heavy backup jobs can slow systems or interfere with service availability. Administrators must therefore schedule jobs during off-peak hours, stagger workloads, or use incremental approaches to reduce load. Performance tuning also involves optimizing network throughput and storage bandwidth, ensuring that backups complete within designated windows. Without such planning, backup jobs can spill into business hours, frustrating users and violating service commitments. The goal is balance, safeguarding data without impeding productivity. Much like road maintenance done overnight, backup scheduling minimizes disruption while still securing the infrastructure. Incremental forever backup designs reduce the frequency of full backups by capturing only changes after the initial copy. Synthetic fulls are later assembled from incrementals, reducing the time and resources required for daily operations. This approach saves bandwidth, storage, and processing power while still maintaining the ability to restore complete datasets. However, it introduces complexity in managing chains of incremental files and ensuring they merge correctly. Incremental forever designs are especially valuable in cloud environments where data volumes scale rapidly and efficiency directly translates into cost savings. They embody the principle of doing more with less, capturing just enough to protect, while avoiding wasteful repetition of unchanged data. Air-gapped or logically isolated backups provide a defense against ransomware and insider threats. By storing copies on systems not directly connected to production networks or isolated through strict controls, organizations reduce the risk that malware or compromised administrators can corrupt them. Air-gapped backups may involve physically removable media or logically segmented vaults that require distinct credentials and approval processes for access. These backups act as the last resort, immune to cascading failures that spread across interconnected systems. In practice, they function like survival caches hidden away from the battlefield, not intended for everyday use, but invaluable if primary defenses collapse. Isolation adds confidence that at least one copy will always remain untouched. Granularity in restore capabilities makes backups more versatile and responsive. Some scenarios call for entire system recovery, while others require the restoration of a single file, object, or specific database record. Without fine-grained options, organizations may waste time and resources recovering more than is necessary. Granularity allows flexibility. A developer who deletes one folder can restore only that piece, while a ransomware incident might call for a full system rollback. Cloud platforms often support object-level restores, while database technologies offer point-in-time recovery for precise fixes. This flexibility ensures that backups serve not only catastrophic recovery, but also everyday operational needs, making them an agile tool rather than a blunt instrument. Configuration backups complement data backups by capturing the state of platforms, applications, and infrastructure. In cloud-native environments, infrastructure as code (IAC) templates may define entire environments. Backing up these configurations allows organizations to rebuild systems quickly and consistently after a disaster. Without configuration backups, restoring data alone may not be enough. Applications may fail to run, security settings may be lost, and dependencies may break. Configuration captures the blueprint, while data captures the content. Together, they ensure both the house and its furnishings can be restored after a fire. In modern IT, overlooking configuration backups is a critical blind spot that undermines resilience. Lifecycle automation leverages metadata, tags, and scheduled events to move backup artifacts through retention phases automatically. For example, backups may begin in high-performance storage for quick recovery, transition to cheaper archival tiers after 90 days, and expire after 3 years unless flagged for legal hold. Automation enforces consistency, reduces manual oversight, and ensures that policies are applied uniformly across massive datasets. In cloud environments where data volumes scale unpredictably, automation prevents human error from leaving backups stranded in costly or non-compliant states. Lifecycle automation is like an automated conveyor belt in a factory. Items move predictably from station to station, ensuring order and efficiency without constant manual intervention. Cost governance is indispensable when retention spans multiple tiers, regions, and providers. While storage itself may be inexpensive, retrieval fees, cross-region transfers, and redundant copies can inflate bills quickly. Organizations must monitor the mix of storage classes, track trends, and enforce budgets aligned with policy priorities. Dashboards, alerts, and reports help prevent surprises and support decisions about trade-offs between cost and resilience. Cost governance ensures that retention remains sustainable over the long term. It is the financial counterpart to technical monitoring. Without it, organizations may achieve resilience but at unsustainable expense, undermining the very continuity they sought to protect. Vendor portability planning prevents organizations from being locked into a single provider's ecosystem. Backups and archives must be exportable in standardized formats, validated by cross-platform tooling, and tested in alternate environments. Otherwise, reliance on proprietary systems may leave organizations vulnerable if providers change pricing, discontinue services, or fail to meet compliance standards. Portability ensures freedom of choice and bargaining power, much like ensuring that electrical appliances can operate with universal plugs. By maintaining exit strategies, organizations guarantee that resilience is not dependent on a single vendor's goodwill, but is instead grounded in flexibility and preparedness for future shifts. Failure scenarios are inevitable, and anticipating them ensures smoother recovery. Certificates may expire, blocking access to encrypted backups. Keys may be lost, rendering archives unreadable. Permissions may misalign, preventing restores. Archives themselves may suffer corruption, particularly if not validated regularly. Preparing for such contingencies requires layered safeguards, certificate monitoring, redundant key escrow, access testing, and data validation checks. Addressing failure scenarios acknowledges that resilience is not about perfection, but about anticipating imperfection and responding gracefully. Much like a pilot rehearses engine-out procedures before takeoff, administrators must plan for failure so that when it arrives, continuity is preserved. Evidence generation provides the documentation backbone that proves retention policies are enforced and effective. Auditors and regulators demand tangible proof. Schedules showing backup frequency, logs recording job execution, test results demonstrating recovery success, and approvals confirming policy alignment. Evidence transforms operational practices into accountable assurances. It demonstrates not only that data is being retained, but that it is recoverable, protected, and governed according to law. This capability bridges the gap between technical execution and organizational accountability, ensuring that resilience is not just practiced but provable. Evidence generation is the written contract between an organization and its regulators, stakeholders, and customers, demonstrating that promises of protection are matched by verifiable action. From a Security Plus exam perspective, data retention concepts must be translated into scenario-driven answers. Learners must recognize when backups, archives, or versioning apply, how to interpret RPO and RTO targets, and how to align policies with compliance obligations. Exam questions may test knowledge of immutability for ransomware resilience, cross-region replication for disaster recovery, or lifecycle automation for cost optimization. By understanding the interplay between these tools, test takers demonstrate readiness not only to pass, but to apply knowledge in real environments. The exam emphasizes practical judgment, choosing strategies that meet both technical resilience and compliance obligations without unnecessary complexity. Data retention strategies achieve their purpose only when they integrate backups, archives, and versioning into a cohesive whole. Backups provide rapid recovery, archives deliver long-term preservation, and versioning guards against human error. Together they fulfill the dual mission of business continuity and regulatory compliance. Layered with automation, encryption, and governance, they become not only safeguards against failure, but also assurances of trust to customers and regulators. In summary, a policy-aligned retention program ensures that data remains durable, recoverable, and auditable, transforming potential liabilities into resilient assets that support both day-to-day operations and long-term organizational confidence. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.